In chapter 14, we are going to be learning about ratios, rates, proportions, how to solve them. And you're going to find that a lot of this is a review. We covered this earlier in the year. We're just going to delve a little bit deeper with chapter 14. So you may want to push pause and copy this, or maybe listen first and then pause and copy it. These are all old vocabulary words, but I wanted to write them just to review them with you to make sure that we understand what these words mean and the difference between them. So a ratio is a comparison between quantities. So if there were 3 girls and 9 boys, we would say the ratio of girls to boys is 3 to 9. There are 3 different forms that we write a ratio using the word to, using a colon, and using a fraction. And all the different forms of the ratio need to be reduced. So 1 to 3, 1 to 3, 1 to 3. A rate is also a ratio, but it's a special ratio of 2 quantities with different units. So this example here is comparing miles to hours. So 120 miles into hours. It could be something like 36 cookies in 2 boxes. The possibilities are endless. Unit rate is what we use a lot. So unit rate is a rate like this, but the denominator, that second quantity, is always a 1. So instead of expressing it as 120 miles in 2 hours, we would express it, the unit rate would be 60 miles in 1 hour. And then we always write out our unit rate using the word per, 60 miles per hour. Per just means 1, okay? You might be given something like, so we'll just call this example 1. Example 2. So something traveled, I don't know what, 2.5 miles in 5 minutes. And we need to express that as a unit rate. So I would start by writing it as a fraction. Okay, and then we want to compare not 5 minutes, but the denominator needs to be a 1. So 1 minute. Well, how do we get from 5 to 1? By dividing by 5. These are like our ratio tables that we did. Divide by 5. And you can work that out off to the side if you need to. But 2.5 divided by 5 is 0.5. So then we would write that as half a mile, 0.5 miles per minute. Wow, that's pretty fast. Okay. So again, you want to make sure you use the word per for unit rate. Okay, so those are all review concepts. Let's jump into the first new concept for today. So the directions will say, find the product, and then it will say, list the units. Guess what? We've done this a little tiny bit. Okay, so now we have to make sure that we really get it. So here's what the problems will be set up like. 8 pounds. So let's say you're buying 8 pounds of, I don't know, potatoes. And potatoes cost $3.50 per pound. Okay, so then it asks us to make this calculation. And the way we want to show it is as fraction work, okay? So just like we can reduce numbers, we can also cross-reduce units. So if we look at a numerator and our denominator, these pounds will cancel out. There's nothing else I can reduce when we multiply fractions we multiply straight across. You can work out the multiplication off to the side if you need to, but I'm confident you can multiply 3.5 times 8. 3.5 times 8 is 28. And the only unit left is dollars. So we found the product and we listed the units. In other words, we included the units in our answer, okay? All right, number 2. So 3/4 hour times 19 miles in 1/4 of an hour. So in other words, something can travel 19 miles in 1/4 of an hour. And we want to know, well, how far can it travel in 3/4 of an hour? So this is what we would call, and you don't really need to know this, but I'm going to tell you anyways. This is what we would call a complex fraction. In other words, it's a fraction that has a fraction in it, okay? So that's fine. We're gonna just have to kind of solve it the best we can. You'll see that you will understand how to do it, okay? So first thing we're gonna do is we're gonna look to see what units can cancel out. So I notice hours on the top and hours on the bottom, those will cancel out, okay? Then I have to work to see what I'm gonna do with all of these numbers, okay? Well, it's really no different. We are still going to multiply straight across, just like we always would, and then make sense of it, okay? So when we multiply straight across, we'll go like this, okay? So let's start with our denominator. 1/4 of 4 is 1. 4 times 1/4 is 1. And then I need to work out 3 times 19, which is 57. Well, 57 over 1 is the same as just 57. We have to make sure we include the units. So miles is the only unit left. So here would be our final answer, 57 miles. Okay. All right, let's try something different. Part 2. Write the ratio as a fraction in simplest form. Okay, so let's take a look at a couple examples. The first one you're gonna notice is like what we've done all along. So let's say you had a test and you got 51 correct and you got 9 of those incorrect. It says we need to write it as a ratio in simplest form. I think a fraction makes the most sense when we're talking about simplest form. So the ratio is 51 to 9. Remember, order matters. 51 is not a prime number. Everyone always thinks it's prime. It's not. It's divisible by 3. 51 divided by 3 is 17. 9 divided by 3 is 3. I can't reduce any more. So here is our ratio in simplest form. Okay, let's try one that's a little bit more challenging. Okay, number 2. So let's compare 2 1/3 feet to 4 1/2 feet. Whoops, I should have put feet there. Okay, so if we use the same idea and we compare it as a fraction in simplest form, it's gonna start out not very pretty. So it's gonna start out, remember, order matters, 2 1/3 compared to 4 1/2. Well, when we do this, okay, we can't have fractions within fractions. We can't have a complex fraction. So step one that I would do is I would make both of your mixed numbers improper fractions, okay? So let's do that together. You may have to watch this a couple times just to kind of get the hang of it. 2 times 3 is 6, plus 1 is 7 over 3. 4 times 2 is 8, plus 1 is 9 over 2. So we still have a complex fraction, fractions within a fraction, okay? So from there, you are going to multiply both the numerator and the denominator by the LCM, okay? And the reason we're gonna do that is because it's going to get rid of the denominator, okay? So remember, anytime we multiply the numerator and denominator by the same thing, it's giving us an equivalent fraction. So when we multiply the numerator and denominator by the LCM, we're just gonna get an equivalent fraction that doesn't have fractions in it. So let's take a look at what I'm talking about. Here are denominators, 3 and 2, okay? So if I use the LCM, which is 6, watch what happens. So I multiply the numerator by 6, I multiply the denominator by 6. This is just finding an equivalent fraction, okay? But if I work this out, 6 is the same as 6 over 1, okay? So now I can reduce these. 3 goes into 3 once, 3 goes into 6 twice. Multiply straight across, 7 times 2 is 14 over 1, but I don't need to write over 1 because that's still 14. And then I do the same thing on the denominator. So 6 is the same as 6 over 1. I'm going to reduce the 2 and the 6. 2 goes into 2 once, 2 goes into 6 3 times. 9 times 3 is 27. 1 times 1 is just 1, and 27 over 1 is just 27. And I can't reduce, okay? So 14 over 7 is my ratio as a fraction in simplest form, okay? So you may want to refer back if you get stuck in your classwork on these, like pull up the video, look at these steps or in your notes, because I know you're taking notes, and rewatch to make sure that you've got it, okay? All right, one last thing we're gonna cover today, which we've already done before. The numbers are just gonna be a little more complex, and that is to find the unit rate. Okay, so we know in a unit rate, we have to have that second quantity as a 1. So if we have, let's say 21 3/4 meters in 2 1/2 hours. Okay, so start it as a fraction. So we're comparing 21 3/4 meters in 2 1/2 hours, okay? And again, when we do the unit rate, we don't need 2.5 hours, we need it terms of 1 hour, okay? So in other words, if I just divide by 2.5, any number divided by itself equals 1. So that's how we're gonna achieve that denominator of 1. Well, to find an equivalent fraction, whatever we do to the denominator, we have to do to the numerator And I can already see your face. I know that you're thinking like, oh, that's so icky. Well, it's not icky, it's just not fun, but you can do it. I know you can do it. So you'll have to work out the division of these mixed numbers. I can show you real quick, but I know that we've done this a lot all year. So we would take 21 3/4, we have to divide it by 2.5 to figure out what that numerator is in our unit rate. So when we divide, the first thing that we need is improper fractions. So 21 3/4 would be equivalent to 87/4. 2.5 would be equivalent to 5/2. Okay, and then division changes to multiplication. And that second fraction, we're going to use the inverse. You may want to reduce first. 2 goes into 2 once, 2 goes into 4 twice. Multiply straight across. 87 times 1 is 87. 2 times 5 is 10. 10 goes into 87 8 times, with 7 out of 10 left over. I don't know, the book might express it as a decimal, 8.7. I don't know why they would do that when they gave us fractions, but maybe. But either these are equivalent, so it doesn't really matter, okay? So I'll just put the decimal in because it's faster, I guess. So 8 7/10 of a meter per hour. I should write it out using the word per hour. Okay, so not very fun, but definitely doable. Okay, and that completes our lesson for 14.1. Feel free to go back, rewind, and rewatch as needed.